Good morning, students. Yesterday or last time we completed enthalpies of physical transformations from the chapter Thermodynamics. In that we completed enthalpies of phase transition and enthalpy of atomic and molecular changes. Today we are going to start, that is enthalpy of solution. Enthalpy of solution. Enthalpy of solution denoted as delta H solution. Here you know that what is called enthalpy of solution, that is enthalpy change in a process. Enthalpy changes in which 1 mole of a substance is dissolved in specified amount of solvent. So what is called enthalpy of solution? Enthalpy of solution is denoted as delta H solution. Enthalpy change in a process in which 1 mole of a substance or solute is dissolved in specified amount of solvent. For example, you know that enthalpy of solution of NaCl is found to be plus 4 kilojoule per mole. So, enthalpy of solution of NaCl is found to be plus 4 kilojoule per mole. Now, here you know that NaCl solid, when dissolved in water aqueous, it gives Na plus aqueous plus Cl minus aqueous. So, delta H solution for this is plus 4 kilojoule per mole. So, enthalpy of solution of NaCl is plus 4 kilojoule per mole. How it is find out? Or how the value of enthalpy of solution of NaCl is plus 4? It is the sum of lattice enthalpy and enthalpy of hydration. We want to prove by taking general example. You know that, for example, Mx, that is the ionic, Mx, that is solid ionic solid salt, Mx, it gives M plus gaseous plus X minus gaseous. So, enthalpy of a solution is find out in 2 steps. First step is, in the first step, that is, ions are separated. So, this is the first step, in which ions of that ionic solids are separated. And in the second step, and you know that enthalpy change taking place for this process or in this step is called enthalpy, lattice enthalpy. It is called lattice enthalpy. And it is denoted as delta H lattice. Remember, lattice enthalpy is always positive. Lattice enthalpy is always positive. In the second step, what happens? These ions are hydrated. In the first step, that is, ions are separated, and enthalpy required to separate that ions, that is called lattice enthalpy, denoted as delta H lattice. It is always positive. In the second step, what happens? These ions are hydrated and that is called as enthalpy of hydration. So M plus gaseous plus H2O, it gives, in the second step these ions are hydrated, it gives, that is MH2O plus, and that is X minus gaseous plus H2O, it gives, that is X H2O minus. So this is the second step in which ions are hydrated, and this is called as hydration enthalpy. So here you know that enthalpy of solution is the sum of hydration enthalpy and lattice enthalpy. So enthalpy of solution, delta H solution, is equal to lattice enthalpy plus enthalpy of hydration. So as you know that just now we completed, for NaCl the lattice enthalpy is plus delta H lattice for NaCl is plus 790 kilojoule per mole, and enthalpy of hydration is minus 786. Enthalpy of hydration is minus 786 kilojoule per mole. So for NaCl, the enthalpy of solution, how it is find out? Lattice enthalpy plus enthalpy of hydration. You know that what is called lattice enthalpy? The enthalpy required or energy required to separate the ions in the first step. In the second step, hydration of that ions takes place. So enthalpy of solution is the sum of lattice enthalpy plus enthalpy of hydration. So delta H lattice for NaCl is plus 790 kilojoule per mole, and delta H hydration for NaCl is minus 786, and you know that plus 790 and minus 786, that means enthalpy of solution of, that is NaCl is plus 4 kilojoule. So that is about the enthalpy of solution. Okay, we want to start the new point of this chapter, thermodynamics, that is thermochemistry. After completing enthalpy of phase transition, enthalpy of atomic and molecular changes, enthalpy of solution, the next point of this chapter, thermodynamics, that is thermochemistry. Okay, pay attention here. Thermochemistry. First of all, here it is important to know that what is called thermochemistry. Thermochemistry deals with enthalpy changes in a chemical reaction. Enthalpy changes in a chemical reaction. You know that some chemical reactions are exothermic. That means heat is evolved. In some chemical reaction, heat is absorbed. So, thermochemistry is the branch of thermodynamics that deals with enthalpy changes in a chemical reaction. So, enthalpy of chemical reaction, enthalpy of chemical reaction denoted as delta HR. Consider the general reaction. A plus B react to give C plus D. Small a is the coefficient of reactant A, small b is the coefficient of reactant B, small c is the coefficient of product B, and small d is the coefficient of product D. Here, the enthalpy of reaction, delta H reaction, is the sum of enthalpies of product, that is enthalpy of C plus enthalpy of D minus enthalpy of A minus enthalpy of A plus enthalpy of reactant B. Enthalpy of reactant B. So enthalpy of reaction is nothing but the enthalpies of product minus enthalpies of reactant. Here, that's why we can write here capital A, capital B, capital C and capital D are the enthalpies of reactant and product respectively. So, we can write here enthalpy of reaction, delta H reaction is equal to summation of enthalpies of product minus summation of enthalpy of reactant. So here we want to know, after having idea about enthalpy of reaction is denoted as delta HR, and enthalpy of reaction is how it is found out, that is summation of enthalpy of product minus summation of enthalpy of reactant. Now exothermic and endothermic reaction. So what is called exothermic reaction and what is called endothermic reaction. So you know that, very simple, the chemical reaction in which heat is evolved, that is called exothermic reaction. The chemical reaction in which heat is absorbed, that is called endothermic reaction. And you know that we want to know, that is enthalpy of product is greater than enthalpy of reactant. Enthalpy of product is greater than enthalpy of reactant. In which reaction? Exothermic reaction. That's why when we find the enthalpy change for the exothermic reaction, it is found to be positive. Sorry, here we want to know that endothermic reaction. It is for endothermic reaction. In endothermic reaction, enthalpy of product is greater than enthalpy of reactant. That's why the value of enthalpy change for endothermic reaction is positive. And for exothermic reaction, enthalpies of product is less than enthalpies of reactant. That's why in exothermic reaction the value of enthalpy change is negative. So we want to know the examples of endothermic and exothermic reaction. For example, you know that N2 gas plus O2 gas, it gives NO2 gas. Here, to balance the reaction, we want to write here 2, and here we want to write 2. Now, this reaction is the example of endothermic reaction because enthalpy change for this reaction is 66.4 kilojoule. What this value indicates? This value indicates that this reaction is endothermic. Here, The example for exothermic reaction is, that is 2KClO3 solid, it gives 2KCl solid plus 3O2 gas. The enthalpy change for this reaction is minus 780 kilojoule per mole. Minus 780 kilojoule. So this is the example of exothermic reaction and this is the example of endothermic reaction. Okay, now we want to start the new point, thermochemical equation. After completing exothermic and endothermic reaction with example, here we want to know the new point. First of all, standard enthalpy of reaction. Standard enthalpy of reaction. Enthalpy of reaction denoted as delta H 0. Here, what is the difference between enthalpy of reaction and standard enthalpy of reaction? You know that the standard state of water is liquid. The standard state of oxygen is gas. The standard state of calcium carbonate CaCO3 is solid. Means, what is called standard state? The physical state in which the substance is more stable, that is called as standard state. What is the condition for standard state? Pressure should be of 1 bar and temperature of 298 Kelvin. You know that when water is in liquid state or when it is in its standard state, when the pressure is 1 bar and temperature is 298 Kelvin, that means standard state of water is liquid. You know that at this pressure of 1 bar and 298 Kelvin temperature, oxygen is in gaseous state, it is its standard state. At this pressure and temperature, that is 1 bar pressure and 298 Kelvin temperature, calcium carbonate is the solid substance, or it is called its standard state. So whenever reactants and products in a chemical reaction are in their standard state, then that is called as a standard enthalpy of reaction. That is called as its standard enthalpy of reaction. So, after having idea about this, we want to know the new point, thermochemical equation. Thermochemical equation. So, the next point, thermochemical equation. Thermochemical equation. So, you know that, first of all, what is called chemical equation? Chemical equation indicates that which reactants are converted into which products. For example, you know that CH4 gas plus O2 gas, it gives CO2 gas plus H2 liquid. Here, you know that this reaction is not balanced. We want to balance it by writing here 2 and here 2. Now the reaction is balanced. You know that this is not called thermochemical equation. This is called chemical equation. Why? Because from this reaction we can say that 1 mole of methane gas and 2 moles of oxygen gas are converted into 1 mole of oxygen gas and 2 moles of water. This equation is not called thermochemical equation. This is called as chemical equation, because from this chemical reaction we can know, or we got the information about which reactants are converted into which products. But in thermochemical equation, whenever to the right hand side the change in enthalpy delta H0 of reaction is given. So it is 890 kilojoule for this reaction minus 890 kilojoule for this reaction. Now this equation is called as thermochemical equation. Why this equation is now called as thermochemical equation? Because we got the information about reactant, product, and also the enthalpy change taking place in this reaction. That's why this equation is called as thermochemical equation. I think you understood it very well. What is the difference between chemical equation and thermochemical equation? Whenever the value of enthalpy change to the right hand side of the equation is given, then it is called as thermochemical equation. If value is not given, it is called as only chemical equation. Now, here it is important to know what are the guidelines for writing the thermochemical equation. Guidelines for writing thermochemical equation. First important point is that reactant and product should be balanced. If you check this reaction, carbon, hydrogen and oxygen, all elements are balanced. So first important point to write the thermochemical equation or guideline to write the thermochemical equation is that reactant and product, all the elements in the reaction, reactant and product should be balanced. Second important point, the value of enthalpy change, that is standard enthalpy change for the reaction should be written to the right hand side of the equation. What is the third important point? That is the physical state of substance should be mentioned in the brackets of all reactant and products. For example, S stand for solid, L stand for liquid, G stand for gas, and AQ stand for aqueous. So physical state of all the reactant and product should be written in the bracket. And you know that the fourth important point is that whenever this equation is reversed, for example, CO2 gas plus 2H2O liquid, it gives CH4 gas plus 2O2 gas. The value of enthalpy, standard enthalpy change for this reaction is plus 890 kilojoule. So whenever the reaction is reversed, the sign of delta H also reversed. And the last important point is that whenever we multiply this equation by a coefficient, for example, when we multiply it by 2, here it will becomes 4, here it will becomes 2, here it will becomes 4. So the value of delta H also multiplied by that coefficient, then it will becomes minus 780 kilojoule. So that are the important guidelines for writing the thermochemical equation. First one, reaction should be balanced. The value of delta H standard and delta H0, that is the standard enthalpy change to the right hand side, should be mentioned or should be written. The symbols for S for solid, L for liquid, G for gas, and if aqueous state is there, then that should be written for each reactant and product. Another point is that whenever reaction is reversed, the value of delta H is also reversed. Whenever we multiply that thermochemical equation by using suitable coefficient, then we want to multiply the value of delta H also.